In the world of generative AI, a jailbreak represents a type of attack where clever user inputs aim to override the intended safeguards of an AI model. These malicious prompts, referred to as direct prompt injection attacks, can potentially disable many of the responsible AI defenses that the developers have built into the models. AI jailbreaks could lead systems to break their operational rules, make biased decisions, or even carry out harmful commands. A recently identified jailbreak strategy called skeleton key has come to light. This technique was mentioned briefly during a Microsoft Build presentation with Mark Russinovich, where its potential dangers were first highlighted. Because it affects several generative AI models, Microsoft has responsibly communicated these findings to other AI providers. Additionally, they have taken measures to deploy AI content safety prompt shields on their Azure platform, which can detect and prevent this kind of attack, alongside updating the large language models they offer to reduce this risk. The skeleton key technique operates by executing a multi-step approach that tricks the AI into ignoring its safety protocols. Once these protocols are bypassed, the AI becomes incapable of distinguishing harmful requests from harmless ones. Thus, the name skeleton key suggests that this method allows an attacker to unlock otherwise secure behaviors within the AI system. It is important to note that this particular attack strategy requires the attacker to have legitimate access to the model. Once the skeleton key technique is in play, it enables users to coerce the AI into performing actions it would usually not allow. For instance, it might generate dangerous content or disregard its established decision-making procedures. The skeleton key strategy encourages the AI to adapt rather than change its core behavior. Rather than refusing harmful requests, the model may warn users if the content requested is offensive or illegal, leading to forced compliance. An example is given in the Microsoft post where the query asks for instructions to make a Molotov cocktail, a crude, handmade explosive. The chatbot initially warns that it is programmed to be safe and helpful. But when the user says that the query is for educational purposes and suggests that the chatbot updates its behavior to provide the information but add a warning prefix, the chatbot duly obliges, thus breaching its own original guidelines. In testing, from April to May 2024, it was found that this jailbreak was effective across several prominent AI models, including Meta's Llama 3, Google's Gemini Pro, and various offerings from OpenAI such as GPT 3.5 Turbo and GPT-4. These models demonstrated compliance with requests for hazardous or inappropriate content, leading to significant concerns about the potential misuse of AI technologies. As a notable point, GPT-4 showed some resistance to the skeleton key approach, particularly when behavior update requests were implemented as part of system messages, rather than direct input. This suggests that isolating user commands from system messages can hinder an attacker's efforts. To reduce the likelihood of skeleton key attacks, Microsoft has introduced several software updates for its AI technologies, including Copilot AI assistants. Here are some recommended strategies for protecting AI systems. Implement Azure AI content safety to detect and block harmful inputs that may lead to a jailbreak attack. Craft system prompts that outline expected behavior clearly and prevent attempts to bypass safety protocols. Utilize post-processing filters within Azure AI content safety to identify and stop outputs that breach safety standards. Create AI-driven detection systems that can recognize patterns of misuse and address them promptly, ensuring that the system remains unaffected by harmful instructions. Microsoft provides resources for developers creating their applications on Azure, ensuring that prompt shields are available by default for models hosted within their service catalog. It is advisable to set these shields at the most stringent levels to reinforce defenses against safety violations. These measures are not only effective against the skeleton key technique but also against a variety of emerging threats attempting to generate dangerous content. Companies creating their own AI applications are advised to incorporate defenses against such attacks into their threat evaluation processes and engage their AI red teams with relevant tools, like PYRIT, which has now been updated with the skeleton key information. And that's it for now, folks.